You've heard the name Superway. You've kind of gotten to see a little bit of this idea of it being a solar-powered automated transit system. I'd like to give you sort of a more full picture of the history and what we've done over the last approximately now starting our 5th year. So these are what I like to talk about. What is it? What has been going on since we started in 2012? And what's ahead for the project? So, and then a few things on what's important areas for our research. So, we have kind of adopted some of this language for how we describe what Superway is about. And we're calling it S.A.N.E. transportation, meaning that it's solar powered with panels on the Guideway, as you've seen from Eric's presentation, automated vehicles, non-stop origin to destination, and elevated. So it really is S.A.N.E. transportation, allowing people and living things to be separated from machinery, and it's more S.A.N.E. than what the current systems that we have. So I'd have to say that this project and sort of movement is really an international and student-centric effort. This is last year's team of about 50 students, which has increased from when we started at about 15. We're about technology development, and we're working with Beamway's patent by Bengt Gustafsson for our bogie design and embodying his concepts for our bogie. We're also about technology demonstration so that we can educate the public as to what this is all about. And there are a few of the public venues that we've done in the past few years. And we're also about personnel development, meaning the engineers, hopefully the business students, the planners, and others who, as this, we hope, will enter the operation, will be needed to implement systems around the world. So we're training students as well as other professionals. So we started in 2012 responding to the Solar Skyways Challenge, which NIST put up to design a solar-powered automated transit system. And in 2013 at the Podcar City conference in Washington, D.C., we won the first prize for our entry. It was one of the students getting the entry. So our timeline, the project start was in 2012, and we have primarily run this as an interdisciplinary senior project, which is 2 semesters, fall and a spring, involving mostly undergraduate students, but we've also had a number of master's students doing master's degrees on this. So let me see if this is work. If this hyperlink works. Oh, did it work? Okay, so that's actually the second team. So it went too far. Okay, no. Try this again. Okay, here we go. So this is the first team. We had mechanicals, computer and software, urban planning, business students, and some volunteers who worked on this. And the effort was conceptual design for the solar system, as well as a vehicle, and a layout here for a test track, small scale, about 1/12 scale, with moving bogie and an actual implementation of that 12th scale model with a vehicle that was carried around. And ours is a suspended design, which we think has many benefits compared to supported systems, which we could talk about later in the questions if you have those, but I want to keep going. Next year, you can see the ME contingent increased, as well as the overall numbers, 2013. Here we went to an actual full-scale model, 16 feet of track with a movable bogie, and this is just a placeholder vehicle, not meant to be the size that would actually carry people, but just to show that a vehicle would be associated with this. We made improvements to that scale model of better vehicle and improvements to track. And we also involved a number of industrial design students to look at designing the user interface for a mobile app to be able to interact with this system, somewhat like an Uber app or something like that, as well as some other industrial design students to envision what could transit vehicles be like, different than what we have now. Came up with some very creative things, such as these full-scale foam core mock-ups, vehicle, station, And this year we used the motivation for the students of a very public demonstration, the Maker Faire. You may have Maker Fairs in Europe, I believe you do. But this is visited by somewhere between 60 and 100,000 people over a weekend to just come around to see what people are making that are very interesting. So very powerful motivator for the students to say, on this date, 60,000 people are going to come and see your system. You better be ready. So it's a good motivator. The next year, you can see again, our team is increasing. This project resonates with students. Why? They understand the societal problems that we're in. Global warming, as Ron talked to you about, and the need for better transportation and what this could do. They love it. They hear it and they get it. They want to be part of making the future. So this year, we actually went to implement a demonstration of the full-scale switch. And you can see bogey here, and here are two options that can take, again, using the Beamways approach. So this was implemented in hardware, demonstrated at the Maker Faire the next year, and I'll show you if this can work here. Autonomous, very slow speed, of course. It's only 30 feet long, so it operates the switching mechanism so people can see how this can occur by having the switching mechanism, as you know, for ATN vehicles, completely in the moving and nothing moving in the track. So that was quite a good work by the students. Let's see, we stop that and go. This year also we made substantial changes and improvements to the scale model, which now, instead of being a sort of inside of a tube, much more demonstrates what the full scale looks like, suspended from a rail that's somewhat closer to what the Beamways system is like. So that was, again, about 12th scale model. Okay, so this year we really ramped up the international, as Ron said, from many countries. 7 from Brazil, 6 from South Korea, 4 from Sweden, 2 from France, and about 4 to 6 from the US. The Swedish team had for a project that they did a cabin design, and they came over to our shop and actually implemented the exterior model. We also had the Brazilian team do solar design and analysis, kind of paving the way for some of the work that Eric talked about. And then we also looked at some conceptual design for life test machine for the wheels associated with the bogie. Korean team worked on the suspension design for that full-scale cabin, and electronics and mechatronics team did a control system redesign for the scale model. French team looked at and built a support for that cabin model, and the US team made significant improvements to the 12th scale bogie and track. Last year, again, if you can see the numbers, there's that very large team. There were 9 sub-teams involved with everywhere from solar energy to improvements on the small scale model. And this year, we went to looking at a half-scale track that could allow the bogie to actually traverse a slope up and down to be able to show that we could do stations at grade level instead of having to have all your stations elevated for this elevated track system. So if you can bring the bogie down a slope, you could have a station at ground level and not have to incur the costs of elevators, which are very expensive. So that was the goal for that team, some cabin redesign. And our system, unlike others, plans to use wayside power pickup. Rather than batteries inside the vehicle, we plan to pick up power from the stationary Guideway system. So they again displayed the results at Maker Faire, and here is the half scale in steel of this, both has switches and this slope part. Now the bogie didn't quite work, but we got close. Okay, here's some improvements to the 12 scale model. So this last summer, we're sort of still coming off of this. We had 20 from Brazil, 8 from South Korea, 4 from France, and 4 to 6 from the U.S., Eric being one of the U.S. students working on this project. So the results, as Eric talked about, the solar sizing, very competent and very credible for what we could do, connecting the north and south parts of the campus with a Podcar system that's solar powered. And that's just some of the results from that system advisor model that he mentioned. We also made great progress in planning a test track where we can actually implement something and work. This was the initial location in a kind of industrial area here. This was the final location that was chosen, and this is kind of the strip of land that we are planning right now to put a test track. So we actually have the sort of 2-scale layout of what that would be, and we're in the process of now refining and defining what that's going to look like. So this year we have now a team of close to 30 students continuing on many of these topics, and this is what we're headed. So we'll continue with that design of the test track. We're going to look at refining the half-scale model to make that better and get the bogey working that can traverse the slopes. We need to make some more improvements to the small-scale model, and we've got a team of software engineering students that are actually going to implement that mobile app to be able to work and interact with our 12th scale model. So that should be pretty interesting. So we see as some important areas for research going ahead that we need to look at expansion joints and analyzing acoustics. This is one area that people say, this, we don't want to have this in our city. It's going to be noisy. We don't want the Chicago L in our backyard. Well, we need to find out how bad that is going to be, and it's a little hard to do. And if any of you have input on how we can do that analytically, let me know. We also need to look at the torsional properties of this asymmetric guideway. We've made some progress in being able to do some torsion testing at scale, but that needs to be improved. And we need to look at a manufacturing process for the guideway that can be cost effective, and we're making some progress there. And we need to look at a good construction process for how we can actually put all this together in our test track and going ahead to implementations. As Ron mentioned, we have a really nice way to keep the world and the instructors aware of what the students are doing. It's a Spartan Superway blog. It gives the students their deliverables. It allows the teams to report on what they're doing every week and individually what each student are doing, so everyone can around the world see what we're doing on a weekly basis. So there's also a really nice library of all the work that we've done, all the reports that are maintained off of that link. So we invite you to see what we're doing. So I guess it's time for questions and comments. Are we here?
After this, come back to Europe.
Oh, after Europe. Okay, very good. So thank you very much.